Ever wondered why voltage dividers are essential, or maybe don't know where they are really used? Because voltage divider is not just about dividing a voltage to get a certain value, because there is more to that. Understanding where it's necessary to use them is crucial, because there are dozens of voltage dividers videos that tells the basics of how it works but don't really explain and show where they are implemented. So let's dive deep into this circuit, building some useful project with it. For most people who don't understand voltage dividers, here is it. A voltage divider is the forming of two resistors in series to get a voltage below our input voltage value at its midpoint. Example, if you take two identical resistors 10k and form a voltage divider supplying 5 volts to its input, we get half our input supply voltage at the output of the voltage divider circuit, which is 2.5 volts. Or if we take two different resistors value, a 10k resistor and a 47k resistor, forming a voltage divider, making 10k the upper resistor, that's R1, and 47k the lower resistor, that's R2, you will notice we get a voltage of 4.1 volt, which is close to our input voltage. And if we switch them, here's what happens. Now you will notice we get a voltage less than 2.5 volt, which is 0.8 volt, which is very low and not really useful for a load. But things are going to get interesting as we move. To find the output of your voltage divider, you will need this formula. So where can a voltage divider be used, or where is it useful? Let's dive in. 1. They are used in setting transistor bias points in amplifiers in order to keep it active. 2. If we form a voltage divider making R2 a variable value and feed its output into our transistor input, you will notice the change of current at the output of a transistor with the help of an LED until the LED goes off completely. But why? That is because the voltage at the input of the transistor has dropped below the transistor threshold point, 0.6 to 0.7 volt for a bipolar transistor, which is not enough to send the transistor into its saturation state. But once that value goes beyond that, as we adjust the resistor, we see the LED begins to light up to full light. Now we can do this manually, right? But how about we replace the variable resistor with an LDR, which is also a resistor that will form a voltage divider with R1, but adjusting its value due to light changes. So currently an LDR resistance should drop due to light in the room and increases its resistance when its surface is blocked from light, and we can see the result on the transistor remaining off until the surface of the LDR is blocked from light, which will increase its resistance, affecting the voltage at the transistor input, reaching its threshold voltage, thus activating it. And that's it. We have simply designed a dark activated sensor switch with the help of a voltage divider circuit. Voltage dividers are also used in setting adjustable voltage regulators reference point, where R2 is always made to adjust certain values at the output. You can see that where I have the two resistors forming a voltage divider at the output of the regulator, and the output is fed into our adjustable regulator pin, while making R1 a fixed value and R2 varying value to match the change in output voltage each time it's regulated. And you can see with the help of voltage divider, we are able to adjust the voltage of our regulator. Voltage dividers are used also in comparators to set their reference point for comparing between its inverting and non-inverting inputs. This circuit is a simple proximity sensor. At the inverting input, you can see we have two identical resistors 10k, which forms a voltage divider that sets the input at a fixed value, which is 2.5 volt. So if the voltage at the non-inverting input, which is a changing voltage value due to the sensor compared with it, if the voltage of the non-inverting is greater than its inverting, the comparator output is going to activate. But if it's less than its inverting, the comparator output stays off. And you can see how helpful voltage dividers are essential in circuits. And you can see it's also used inside a 5-5 timer. If you want to understand how a 5-5 timer works or a comparator, I think you should check out any of these two videos made for you. Link in the description box. Where else have you seen voltage dividers used in a circuit? Comment below. I hope this video helped you. Why not give us a like, leave a comment, and hit that subscribe button if you want to see my next interesting video coming up. Thank you.